In this video, I'm going to show you about how to rationalize the denominator of an expression. Okay, so here you can see that there is a root under a. So there is a root or the surd in the denominator. On number 2, there is a root a plus 1. There is also root, right? And in number 3, there is also root in the denominator. So our goal is get rid of that root from the denominator. Okay, so there are 3 different cases. The first case is there is only one term in the denominator and that has the root. So if you want to rationalize, meaning if you want to get rid of that root from the denominator, what we do is you divide and multiply by that exact the same number, root a over root a. Okay, so if you do that, then there will be the number 1 times root a will be root a on the top, and at the bottom there is root a times root a is just a. That's what you get. Okay, but if there is something else in the numerator except a, if there is like 2, 3 or anything, you multiply that with that root a. Okay, the second type of problem you will see is there are 2 terms in the denominator. One it has root, the other does not have root. Root a plus 1 or root a plus b, you will see like root a plus b. Let's think like that. Okay, in this case what you do is you multiply and divide by the conjugate. What do you mean by conjugate? Conjugate is exactly the same expression, but the sign in the middle will be changed. So what I do is I multiply and divide by root a minus b divided by root a minus b. So I divide and multiply by the same expression, but how do I pick that expression is exactly the same thing in the denominator except the sign in the middle of those 2 terms. There was plus, I change that sign to minus, and I'm multiplying and divide by the exact same quantity there. Okay, if you do that, then what you will get is 1 times root a minus b will be root a minus b divided by it is root a plus b times root a minus b. You just FOIL it, right? So you will get root a times root a is a, root a times negative b is negative root a b, and then b times root a is positive root a and then b, right? That b is outside the root. Okay, that a is root is only for a, and then b is outside, and then b times negative b is negative b square. You see that? So what do you get? You cancel out positive and negative root a times b. So your final answer look like root a minus b over a minus b square. That's what you get. So see, on this example 1 and example 2, at the question there was root, but in the answer there is no root, meaning we rationalize that irrational number, because whenever there is a root we call irrational number, and we get rid of that root and then got the a number without root, so on the denominator. Okay, the similar thing here, there is root a plus root b, you multiply by the conjugate, we call that as conjugate. Okay, the conjugate of root a plus b is root a minus b, we call that conjugate. But the conjugate is usually used for the complex number, but even in the real number case or the rationalized problem case, we call it conjugate, not a problem. So root a plus b, so what you multiply and divide is root a minus root b, right? And then root a minus root b, you multiply and divide by the same quantity, but the sign changes. So you multiply and divide by that expression, but the sign changes in the middle, but you need to have the same thing in the top and bottom. So exactly the same idea. So multiply 1 times that is root a minus root b, divide by, you FOIL it, root a times root a is a, right? Root a times negative root b is minus root a times b, right? And then root b times root a is plus root a times b, and then root b times negative root b will be negative b. You see that? You cancel out again. So what is your final answer is root a minus root b, and then divide by a minus b. See, the denominators are free from roots. This is how we do the rationalize the denominator. Let us see some examples that has number instead of a and b. Let us do the example a. There is only one term, right? What should I do to get rid of that root is you multiply and divide by the exact same number there, root 7 over root 7. So what do you get? Root 7 times 1 is root 7, right? Divide by root 7 times root 7 is 7. That's the answer. That's the final answer. Because the denominator is free from root. How about B? There is 2 root 3 in the denominator. You can keep 2 or multiply and divide by 2 root 3. That's perfectly fine, okay? So what you can do is just don't worry about the numerator. Just look at the denominator. So there is 2 root 3, right? There is only one term. So you can multiply and divide by 2 root 3. Or you can multiply and divide by root 3 only, because that is the only that has root, right? So you can do root 3 divide by root 3. So what is root 5 times root 3? You can write root under 5 times 3. You can do if there is a product. If there is plus, you cannot write a single root. You would have to write root 5 plus root 3 if there was plus in the middle. See, there is a product. You can write a single root and then write 5 times 3. So this will be 2 times root 3 times root 3 is just 3. So what you get is root under 15, because 5 times 3 is 15 over 6. See, the denominator is free from root. So this is how you do rationalize the denominator if the denominator has only one term with root. Okay, on this problem, this is similar to the example 2. There are 2 terms in the denominator, right? But there is one has the root. So what you do is multiply and divide by root 3 minus 1, because we do the conjugate of that sign in the middle. Divide by root 3 minus 1. So if you simplify the numerator, 1 times root 3 minus 1 is root 3 minus 1. Divide by root 3 times root 3 is 3, right? And root 3 times negative 1 is negative root 3. And then 1 times root 3 is positive root 3. And then 1 times negative 1 is negative 1. You see that? Negative root 3 plus root 3 will be 0. So what is left is your final answer will be root 3 minus 1 divided by 3 minus 1 is 2. This is the final answer. And you should be very careful when you write the root. This root is only for 3. You cannot extend that root to 1. This root is only for 3. Similarly, look at this example. You don't have to worry about the numerator. Just look at the denominator. This has root. You want to get rid of that root, right? So what do? You do the conjugate again. Root 3 plus 2 divided by root 3 plus 2. You see that? And then what do? Is you multiply the top with that. So 5 root 2 times root 3 will be 5 times root 3 times 2 under the root, because this is the product. And then plus 5 root 2 times 2 is 5 times 2, because you multiply root with the root, non-root with the non-root, right? So what do? 5 root 2 is distributed to root 3 and then 2 separately. 5 root 2 times root 3 will be 5 times root 3 times 2. And then 5 root 2 times 2 will be 10 times root 2 or 10 root 2, because 5 times 2 is 10 and root 2 is just root 2. Here 5 times root 2 times root 3 is that one, okay? Now in the denominator you 12, root 3 times root 3 is 3. Root 3 times 2 is plus 2 root 3. Usually if you are multiplying root and then without root number, you write the with non-root number first and then times the root number after that. And then minus 2 times root 3 is 2 root 3, okay? And then minus 2 times 2 is 4. You see that? Now this and that are the exactly same number with opposite sign, so they subtract each other. So what is left is 5 times root 6, 5 root 6, and then plus 10 root 2, right? Divide by 3 minus 4 is negative 1. That's the final answer. You see that? So I mean, if you want to, you can factor out 5 and then write like 5 and then root 6 plus 2 root 2. What did I do there? Over negative 1, or you can move that negative sign in the front. That is perfectly fine. You can stop here, or you can write negative 5 root 6 plus 2 root 2. you can end up like that too. So either of these three are fine. But what I'm doing here is, there is 5, this 10 is 5 times 2, right? So if I take 5 out, that is 5 is the common factor. If I take 5 out, then what is left is root 6 and plus 2 root 2. You can end up like that too. So this, either this form or this form or this form, all of them are good. Now the last example is, we don't have to worry about the top. Look at the denominator that has root 3 plus root 5. So you need to do the conjugate. Like example 3, what you do is root 3 minus root 5, okay, divide by root 3 minus root 5. You see that? Now you FOIL the top. Root 3 times root 3, root 2 times root 3 is root 6, and then root 2 minus root 5 times negative root times negative root 5 is negative root 10. You see that? This is 10, and then 1 times root 3 is plus root 3, and 1 times negative root 5 is negative root 5. That's what you get. Okay, in the denominator, root 3 times root 3 is 3. Root 3 times negative root 5 is negative root 15. You see that? And plus root 5 times root 3 is positive root 15. I'm just using FOIL, right? FOIL. Root 5 times negative root 5 is negative 5. So what is left there is that cancel out, right? Root 6 minus root 10 plus root 3 and then minus root 5 divided by how much? Negative 2. That is the final answer. Okay guys, so this is how we rationalize the denominator of any expression that has root in the denominator. Alright, thank you.